And you could consume 100 gigabytes of data for the same amount of 15 hamburgers is 100 gigabytes, roughly. So it's kind of interesting. But so that's sort of what it takes. And that's just locked into the physics of how you make things, how you add value to the things in the real world. But think about the scale of each of those things, right? We produce each year hundreds of millions of cars and hundreds of millions of smartphones. We create and operate trillions of room hours, like this room around the world. We fly 3 trillion air miles a year in the world. We consume trillions, as we know from McDonald's signs, hamburgers in the world. And we consume a zettabyte of data a year. I mean, the numbers are incomprehensible. In fact, the last thing I'll talk about information is how incomprehensible these numbers are in the scales. I mean, information is very, very light, obviously. That's why your iPhone is so light. That's why data centers are so big, by the way, because the energy is behind it all. But the zettabyte era, which Cisco writes and talks about, some of you have read this, right? They do a thing they call the zettabyte era. If you haven't seen the report and you want to be blown away by the quantity of data in the world, just Google up Cisco zettabyte era. And their report's really a tour de force tracking the magnitude of growth in data in the world. I'll put it in 2 terms to give you a sense of what matters. First, in scale terms, second in money, because in the end, it's always about the money. And that's what I'm going to get to in a minute. It's always about the money, and it should be. Money is a precious thing. Money represents the most precious thing that human beings have, which is our time. That's why money is precious, fundamentally. It's about our time, which is something that can never be replaced. Everything else is infinite. Time is not for humans. But let's scale. It's a zettabyte. So a zettabyte, I don't know about you. I don't know about you. But the prefixes, the suffixes and numbers of scale are hard. A zettabyte's 10 to the 21. So if you remember your high school math, an exponent of 10 to the 21 is a big number. But each byte doesn't consume much energy, right? It just doesn't. I mean, we measure the consumption of bytes in what are called picojoules. A picojoule is a thousandth of a trillionth of a unit of a joule of energy, which is a fly when it lights on your hand doesn't generate sort of a few hundred picojoules. So we're talking about not very much energy per byte. But we consume, produce, store, and transmit 10 to the 21, a zettabyte worth of bytes a year. How big is a byte? I want to give you a sense of perspective of why these two worlds collide and why I think we win, because this alone sort of illustrates it. So if I had a zetta stack of dollar bills, right? Dollar bill is pretty thin. And if I stack that stack up, that stack, to get a zetta stack of it, would go to the sun, which for those of you who have forgotten your high school astronomy is 93 million miles away, so that's far. They go to the sun and back 1 million times. That's what that number means. So I would suggest to you that if each one of those little bytes consume an infinitesimal amount of electricity, probably all together it consumes a lot. One last factoid. We consume electricity because we manufacture transistors that consume electricity. It's that simple. That's it. Each transistor doesn't consume a lot, but we make lots of transistors every year. And we use energy to make the transistors, and the transistors use energy when they run. And they run all the time. We manufacture in the world today more transistors than we grow grains of wheat. I didn't say bushels. I didn't say tons. I said grains of wheat. We manufacture more transistors than we grow grains of wheat. And they all consume electricity constantly. This is the scale of the world we now live in. This is the ascendant world in which, again, the iPhone toting acolytes of the apocalypse love.